So today we're going to talk, since we took all the individual days last week to do the little bitty parts, today we actually get to start using those. And we're going to talk about solving quadratics. Okay? We're going to solve quadratics today 3 different ways. First of all, we're going to solve it by graphing. Second of all, we're going to solve by square roots. And third of all, we're going to solve by factoring. Okay, those are the 3 ways that we're going to solve quadratics today. Is this the only way to solve quadratics? No, there's like 57 ways to solve quadratics. Okay, I'm going to teach you like 12 of them. So we'll start with these first 3. For the record, that was just a little bit of an exaggeration, not 12. Okay, maybe like 5. Okay, but here's the first 3: graphing, square roots, and factoring. You got that? So if we're doing all 3 of these in one day, what does that mean? Probably easy, and probably more likely you've seen it before, right? So today I'm just reminding you how to do all this. Is that okay? So let's start off solving quadratics by graphing. Negative x squared plus 2x plus 3 equals 0. So this is an equation that we're trying to solve. Okay? And we're trying to solve it by graphing, right? So should we start with a graph? Yeah? Okay. So negative x squared plus 2x plus 3. Enter. Where are the solutions? So that actually makes me really happy that you said that. Okay? Because typically when I say where are the solutions, people always say -1 and 3. Well, we don't know that for sure. We're just looking. That gives us a place to start. But what you guys said instead is where the graph crosses the x-axis. That actually makes me very happy because that tells me that you have the knowledge to solve this, even if these aren't nice and pretty, right? What we're looking for are the zeros. Where does this graph cross the x-axis? Okay? Very happy. Did I tell you that already? You made me very happy? Okay, good. So, now some of you did say -1 and 3, and that's perfectly fine. Okay? Some people answered specifically for this problem. Some people answered in general, right? Okay? But my question to you is, are you positive that it's -1 and 3? We can't be positive just by looking at the graph, can we? There are a couple ways to be positive. Do you know any of the ways? So we could do Control T. What does Control T do? Pulls up the table, okay? And if we're looking at the table, what should we look for on the table? So you guys said -1 and +3, right? Well, what's true about x equals -1? Y equals 0. Is that a 0 then? Yes. Are you sure that this graph is crossing the x-axis at 0? Yes. Now you're sure, right? +3 was the other one you said. Oh, look. Another 0. Control T. I want the table to go away for a second. Is there another way you can know where it crosses the x-axis? What you got? You could, but we're trying to stay away from that right now. Okay? So menu. What? Oh, analyze. Okay. Oh, look at the very first one. 0, right? So it's saying lower bound. It's saying put this dotted line on the left-hand side of where it crosses. And now it says upper bound. And I scoot it over. Oh my goodness, -1, 0. And if you can't see that very well, you can always go hover with the hand right here and do Control the middle click. So now just closed so you can move it around to see it very clearly. Yes? And then we would have to do it again, right? Menu, analyze. It won't do both of them at the same time. Okay? You have to do them one at a time if you're doing it this way. In this particular case, the table was easier, right? Because we saw right away where they were. When would this way be appropriate? When it's probably like a decimal or a fraction or a square root or something like that, right? Something that's not a whole number or an integer, yes? I guess I could have just said integer and taken care of all that, right? Okay. Regardless, let me zoom back out so you can see my work. Why did I dot my C? That's super weird. Regardless, what are my two answers? Okay. Now for your work, what do I want you to sketch? Just a little quick sketch. Doesn't have to be perfect, but it needs to cross the x-axis at -1 and at 3, right? And it probably needs to be opening the correct way, doesn't it? Okay. So let's be clear. The solutions, just like you said to me earlier, the solutions are where the graph crosses the x-axis. Do these have name? Oh, they're called the x-intercepts. The x-intercepts. It's the x-intercepts. Does that make sense? Do I need to do any more examples of those for you, or you got that okay? Got it okay? All right. So now let's solve quadratics by square roots. Here's some notes about solving quadratics by square roots. Okay? And I've got 3 examples for this kind of problem. Okay? First of all, what if it says a squared equals 81? Like a super simple problem, right? How do I solve for a? Yeah, because how do I undo a square with the square root? Plus, you already knew that because it says square roots right there, right? Okay? Now, please don't allow yourself to be tricked on the question I'm about to ask you, okay? What do you get when you take the square root of a squared? What do you get when you take the square root of 81? Okay, that's what I was afraid you were going to say. I was afraid you were going to say 9. Okay, so my question to you is this. What times itself equals 81? I agree with 9. I'm not saying that I disagree with it, but I'm asking you this. What else times itself equals 81? -9. Okay? So when we answer this, we got to put a plus or minus. Remember? Fundamental theorem of algebra, the highest exponent says that's like the most solutions that you'll get, right? I don't want one solution if I take a square root. I want 2, right? Any questions about that one? Okay, what about if this is the problem? P minus 4 squared equals 49. Now I'll tell you this, some really crazy people, they want to take this and say P minus 4 times P minus 4 and distribute, and then minus the 49 and then try to factor it again and get this. Oh, that's exhausting. Isn't this a squared term? Then can't I take the square root of it? What is the square root of P minus 4 squared? P minus 4. Anytime I square root something that's being squared, I just get that thing, right? Equals what? Dang it! Okay, plus or minus 7. Now we have to use our brain a little bit. I know, it'll be fine. If I add 4 to both sides, I have to say to myself, self, what is 7 plus 4? Self, what is -7 plus 4? -3, right? You can't just do 7 plus 4 and plus or minus 11, can you? You've got to do positive 7 plus 4 and -7 plus 4. Does that make sense? I got one more for you for square roots as an example. You ready for it? Okay. What about this? 2 times x plus 2 squared minus 5 equals 8. What should I do first? If I add 5 to both sides, what do I get on the left-hand side? Still 2 times x plus 2 squared, right, equals what? 13. What's my next step? So if I divide by 2, so that makes me, another thing that you've done today that makes me very happy, what I was trying to do was isolate the thing being squared, right? Because once I isolate it, what can I do now to it? Just square root it, right? Okay, so on the left-hand side, or excuse me, on the right-hand side, I just have 13 over 2, right? I do not want to go to a decimal here. I do not. And you'll see why in just a second, okay? Now that I have the square root, or excuse me, now that I have the squared thing being isolated, what do? Square root. On the left-hand side, I have x plus 2, and on the right-hand side, I have, uh-oh, am I allowed to have a fraction inside of a square root? No, because when I do, that means I have the square root of 13 over the square root of 2, and I for sure can't have a square root in the denominator, can I? Man, I'm glad we worked on this last week. It's almost like I planned it like this. Oh, okay. What do I have to multiply this by? 1, right? A value of 1. What value of 1 should I choose for this problem? Square root of 2 over the square root of 2. And why did you choose square root of 2 over square root of 2? So that can turn it into something I know the square root of in the denominator, right? In the denominator, I know that the square root of 2 times the square root of 2 equals the square root of 4, which is 2. And in the numerator, I have what? Square root of 26. Good. So the right-hand side of this equation down here is the square root of 26 over 2. Almost. What am I missing? Very good. Plus or minus. So when I subtract 2 on both sides, x actually equals negative 2 plus or minus the square root of 26 over 2. Now I want to do this right here if I can, right? Can I do 7 plus 4 and get 11? And negative 7 plus 4 and get negative 3? Guys, is there any way I can simplify negative 2 plus the square root of 26 over 2? No. So is it okay if I just leave it like this? Absolutely. Any questions about solving quadratics by square roots? Isolate your square root. Let's write this down. Isolate your square root and then square root both sides. To solve, right? What should we not forget? Don't forget your plus and minus. Just some little hints to write down for us to when we're solving these, yes? Any questions? You got it okay? If you get started on your homework and you do have questions, what should you do? Oh, excellent. Ask them. Okay? Solving or solve quadratics. What's left? By factoring. 0 equals z squared minus 10z plus 25. Guys, what's to stop me from putting this into my calculator and just seeing where it crosses the x-axis? What's stopping me from doing that? The directions, right? Your work has to match the directions for you to get credit for it, don't you? Doesn't it? Not don't you, doesn't it? Okay, so if it says solve by graphing, for sure, plug it in the calculator and graph it. But it says solve by factoring, your work has to prove that you solved it by factoring, yes? Okay, so how should we factor this? Oh, AC? AC and B? Okay. What's AC? 25. And what's B? So what multiplies to be AC and adds to be negative 10? Negative 5 and negative 5. So Z minus 5 and Z minus 5. Remember the zero product property. If you multiply two numbers together and you get an answer of 0, what has to be true about one or both of them? It has to be 0, right? So we always, just to make sure to cover all of our bases, we have them both equal to 0, don't we? Z minus 5 equals 0, and Z minus 5 equals 0. That seems familiar. Oh, I already did that one, right? Do I still have to do both? Because how many answers should I get? So even if they're both the same answer, is that okay? Well, it has to be, because we just did it, and we did it right, and that's what happened, right? Do you remember what this is called? This is actually called a double root. Okay? What's true about the graph of a double root? Do you remember? That's where the vertex is, isn't it? So if you look at the graph, it looks like there's only one solution, but there's still really two. It's a double root. It's one solution twice. You okay with that? I mean, even if you're not okay with it, that's what happens. So we just have to kind of go with it, yeah? Okay. Another? Okay. X squared minus 11x equals negative 30. X squared minus 11x equals negative 30. Anytime we're trying to solve a quadratic, what must it equal? 0. So we've got to do something first to make it equal 0. And what's that thing? So if I add 30 to both sides, x squared minus 11x plus 30 equals 0. Since it's a quadratic, AC. AC is 30, B is negative 11. So somebody who didn't answer last time, if you already answered, you be quiet for a second. You're not in trouble. I just want to make sure everybody has a chance. What two numbers multiply to be 30 and add to be negative 11? So we have to make sure the signs are correct, right? So negative 6 and negative 5, are you in agreement on that? Guys, why can I go straight to the factors instead of having to split my middle term? Because the leading coefficient is 1, right? Okay, that's why I can go straight to my factors. You remember that? Some of you are ready for this, so I'm going to do it for one and not for the other, just for those of you who are ready. Okay? If you're ready, from here, you can go here. Does that make sense? Some of you still need this. But if you're ready, you can go from here to here. See what I'm saying? Like I'm skipping this step right here on this first one. And if you're ready, you have permission to go ahead and do that. Okay, so far? Can I do one more example for you? Okay. I mean, I'd say thank you for your permission, but I was going to do it anyways. But Guys, because of how we factor our trinomials, what if we have a choice? We always want our squared term to be positive. Positive. Okay? If we have a choice, we want our squared term to be positive. So where should I move all this stuff? So over to the right side, right? Because if I move this over here, that's going to give me a negative y squared term, isn't it? Okay? So minus y squared, plus y, and then minus 28 on both sides. Yes? What do I end up with on the left-hand side? 0. What about the right-hand side? So really it depends on where you are, like in your mathematical thinking at this point, right? Because some of you want to start with y squared, don't you? Since that's the order we need it in. Some of you need to bring everything down first, like combine everything and then put it in the right order. Is it okay if I go ahead and put it in the right order? Okay, so I'm starting right here actually. 2y squared minus y squared gives me y squared. And then I have 2y and a y, 3y. And then I have minus 28. Is everybody okay with that? I did kind of skip a step in there of just bringing it down first and then putting it in order. Are you all right with that? Okay. And now, AC is, and B is. So somebody who hasn't spoken yet, tell me what two numbers multiply to be negative 28 and add to be positive 3. 7 and negative 4. That's exactly right. Once again, because my leading coefficient is 1, I can go straight to my factors. X plus 7, x minus 4. Zero product property tells me I can set both of these equal to 0. So x equals and x equals 4. What questions do you have? Somebody asked me a question that you may necessarily don't have, but you think somebody else might have. What questions could pop up here? What if you change the letter? Okay? Did you notice that I changed the letter? That was totally by accident. I wasn't paying attention. Okay? It's a y at the beginning. It should end up with y, right? So this should be y, and this should be y, this should be y, this should be right. Does it change the values of my solutions, though? No, so that's a good question. What was the other question you had? What if the leading coefficient is not 1? What would we have to do then? We'd have to split this middle term, right? We'd have to split it into two parts and then factor by grouping. Do you remember that part? Okay. Any questions? Those were great questions, by the way. Are there any more?